Okay, so in this section now, what we're going to start looking at, as you can see here, is logarithms. Namely, we're going to look at what's called the logarithmic function with a base a, where a is positive, but a is not equal to 1. We're going to use these logarithms to work with exponential and logarithmic statements. Namely, we're going to convert from one to the other. We're also going to look at logarithmic expressions, and we're going to look a little bit more at the logarithmic function. Specifically, we're going to see the domain, and we're going to see the graph of these. So let's jump right in and let's look at the definition. So here's the definition actually. As you can see, we have it right here. The a has to be positive, but it can't equal to 1. And this is actually how the logarithm, this is the notation for it. It is another function. The actual definition is based on the exponential function, and this is actually how it's defined. Namely, the logarithm with base a of x, that's going to be equal to y exactly when a to the y is equal to x. There is actually a very good visual way of remembering that using what's called the log roll, which we'll see shortly. But really, this is actually the definition of it. And if you remember with exponential functions, the range of an exponential function was only positive numbers. The exponent was any number you wanted, but the output was only positive numbers. Well, because of that, using the definition, we get the logarithm with base a of x. This is only defined for positive x. In other words, the domain of this function is all positive numbers. And we'll also see, I didn't write it here, but we'll see later as well, that the range turns out to be all numbers. And this is something else also that's good to know. Whenever you have an exponent, such as a raised to something, you have what's called an exponential statement. When you have a logarithm, then you have a logarithmic statement. And using the definition here, you can actually go from one statement to another. Now, the definition is a little tricky, and I understand that. But there is something called a log roll that you can use. Namely, if we have log base a of x equal to y, again, this is the same as saying a raised to the y equals x. So this is the same as saying a raised to the y equals x. So it's almost like down here, you have raised to, and you have equals up here. You don't really need the raised to and the equals words, but it does help you remember how you evaluate the logarithm. This is what a log roll is. Okay? That's, again, just what it is by definition. Now, what we're going to do is use that to actually convert each exponential statement here to a logarithmic statement, and any logarithmic statements to an exponential statement. Being able to convert from one to the other is actually very useful. In the first one, we have 2 to the x is 7.2. From here, we can actually obtain the logarithmic statement. Now, what you could also do is you could do this. You can actually consider a log roll to solve this, and you just check to make sure that indeed what you have is 2 to the x is 7.2. I mean, we can see that from here. If you wrote this down using a log roll, right, you would have 2 raised to x, right, 2 raised to the x equals 7.2. So I guess so really that's the best way to remember this. So for instance, in the next one, notice here we don't know what a is. All we know is that a is positive and not 1. So from here, we're going to have log base a of 2.1 is equal to 3. And again, how do I know for sure that that's right? Let's do a log roll. we have a raised to the third, right? A raised to the third equals 2.1, which is exactly the same statement we have here. So we know that the answer is right. Over here, we have log base a of 2 equals 7. Well, here again, we can just jump right into a log rule. We have a raised to the 7 equals 2. Now, what exactly is a? Honestly, I don't know. But for the moment, it doesn't matter. Here, remember, e is a special number. It's irrational, but it's about 2.71. It actually is irrational. Remember, irrational means you cannot write it as a fraction of integers. But it does denote a special number. So here, using a log rule, we have e squared. Okay, actually, let me do this. E squared equals, so we have e squared equals b. So we have another example done as well. Excuse me, let me just fix this. Okay, like so. We can also actually figure out the exact value of certain logarithmic expressions. I mean, you could use a calculator as well, but here, as you'll see in these examples, you actually don't have to in certain cases. But it's still good to have a calculator handy with you. I know the iPhone calculator, you can use that to evaluate log of any base. So for instance, if we have log base 3 of 27, well again, using a log roll, what we actually have is this. First, I'm going to say, let's let log base 3 of 27, I'm going to call that number y. Now, why did I do that? Well, because from then, we can do a log roll to get 3 raised to the y must equal 27. So 3 raised to the y is 27, which is how I got this statement. Okay, how does that help us? Well, we already know 27 is 3 cubed. You know, that's just direct calculation. So really, if I substitute, I get 3 to the y equals 3 cubed. And if you remember what we saw about exponential equations in the previous section, from here, you can actually obtain, since the bases are the same, we get the exponents have to be the same. Thus, we get y has to equal to 3. Not to mention also, you could even check it. If we have log base 3 of 27, is this going to be 3? Well, let's do a log roll. We have 3 cubed. This is saying 3 cubed, right, would equal to 27. So 3 cubed would equal to 27. Well, this is true. So yes, our answer is correct. Okay, so that's good. Okay, so let's do some more examples now. So here we have log base 2 of 8. Okay, so just like before, I'm going to let I'm going to let log base 2 of 8 equal y. I know usually y is supposed to go on the left, and we're really supposed to write y equals, but for the purpose of solving this problem, for figuring out what log base 2 of 8 is, let's write it this way. And so doing a log roll, we have 2 raised to the y must be 8. Okay, so this is saying that 2 raised to the y, that's going to be 8. Now we know that 8 is also 2 cubed. So because of that, what we get is 2 cubed is 2 to the y. Let me just fix that. 2 to the y is 2 cubed. And just like before, that means y has to be 3. And if you want to check it, you can. If you do log base 2 of 8 equals to 3, well, is that true? Well, this is saying that 2 cubed is equal to 8. Well, that is true. 2 cubed equals 8. So yeah, that's how we know this answer is right. Now for this one's a little bit different, as you can see. So here, what I'm going to do is write this. Log base 4 of 1024. I'm going to let this be y. So then this is saying, again, doing a log roll, 4 raised to the y equals 1024. So we have 4 raised to the y is 1024. Now 1024, just fix that a bit, 1024, you can actually write as 4 times 256, which is 4 times 4 times 64, and that's equal to 4 times 4 times 64 is 16 times 4, and 16 we know is 4 squared, so we have 4 times 4 times 4, and 16 we have is 4 squared, so what we actually have is 4 to the 5th. So 4 raised to the 5th is 1024. So because of that, just like above, we have 1024 is 4 to the 5th, and 4 to the y is 4 to the 5th, and so we get y must equal to 5. You could check it like above, namely, if we have log base 4 of 1024, is that equal to 5? Well, again, if we did a log roll, this is saying 4 raised to the 5th has to equal to this, 1024. And yes, that is true. Good. For this one, log base 9 of 3. So again, I'm going to call this number y, okay? So this is saying, using a log roll, 9 to the y must equal to 3. So we have 9 to the y is equal to 3, as you can see. Okay, now the question is, how do we get this? Well, if you remember, we know that 3 is equal to the square root of 9. And when you take the square root of something, that's the same as raising it to the 1/2 power. So in other words, from here, we have 9 to the y is equal to 9 to the 1/2, and so y must equal to 1/2. And just like checking it as before, log base 9 of 3, is that 1/2? Well, again, doing a log roll, you would have, excuse me, let me change the color a bit. You would have 9 to the 1/2 would equal to 3. Hence, 9 to the 1/2 is 3, and we know that's true from the above, so this is the right answer. Good. So we get y, this is the right answer.